Machephy Eduworld.
Force on a current carrying conductor, that is F is equal to I dl cross P. Then we also learned force on a charged particle in a magnetic field, that is F is equal to Q V cross P. We have learned then magnetic field due to a current carrying element, that is mu naught by 4 pi I dl cross R upon R cube. In this one, we had the first formula for a straight line, and that was mu naught I by 4 pi R sine phi 1 plus sine phi 2. Phi 1 and phi 2 are the the projection angles with the points for a circular section. We had this formula, mu naught I by 2R, theta by 2 pi. That is, this is for a straight wire. This is for a straight wire, and this is for a circular wire or circular arc. We're going to apply all these formulas, and we're going to hit up some numericals today. Okay, and I'll tell you the value of mu naught, that is 4 pi into 10 raised to minus 7 in the SI units. These are all the formulas. Let's start doing problems based on this. So first question is that there is a square loop, and the side of the square is A. Side of the square is A, and it carries the current in the anti-clockwise direction, I. So first thing, you have to find a magnetic field at the center O. Okay, we also learned about the formulas of magnetic dipole, M. So M vector is N I into area vector. And torque on a magnetic field, on a magnetic dipole is mu cross B, or M cross B. M cross B, and potential energy is minus M dot B, just like the electric dipole. All these formulas we're going to use. So here in this case, you have to find magnetic field at point O. Then you have to find, of course, you have to find the direction also. Then you have to find the magnetic dipole moment of loop. Mehul, tell me the answer with the value of magnetic field.
Sir, I got root 2 mu naught I.
Root 2 mu naught I. So it will be mu naught by 4 pi, and distance will be A by 2. And each of the point is making an angle of 45 degrees. So this will be sine 45 plus sine 45. And the current is I. So sine 45 plus sine 45, that will be root 2. So mu naught by 2 pi into I by A into root 2. Also, all of them will be giving magnetic field out of the plate. And the net magnetic field will be this thing multiplied by 4. Because there are 4 wires, all of them are giving magnetic field in the same direction. So this will be 2 root 2 mu naught I by pi a. Anyone got this answer? See, you have to apply this formula. This is for a straight line. You have to apply this formula. Mu naught I by 4 pi r sine phi 1 plus sine phi 2. There are 4 straight wires. So for each straight wires, you have to calculate. And at center, the distance of the wire from the center, that will be this r. Mehul, did you understand?
Yes, sir.
Okay. Okay, next find the direction will for this will be out of the field. I'll put a dot here then. Next find the magnetic moment. Mehul, tell me the magnetic moment. It will be current into area and direction will be
outwards.
outwards. So current will be I, area is a square, and out of the plane. That will be the magnetic dipole moment. Okay. Next, let us say we have a shape like this. And there's a current in this loop. Current is I in the anticlockwise direction. The side length is A. It's an equilateral triangle. Equilateral triangle. So first thing you have to find is the magnetic field at the center O. O is the centroid. O is the centroid. And you have to find magnetic field at O. Then you have to find the magnetic dipole moment. Then it is given that there is an external magnetic field B along this direction. A uniform magnetic field B naught along the x direction. So you have to find the torque on this, then find the potential energy of this magnetic dipole due to the magnetic field, of course. This side is A. Each side is A. Rishit, tell me the value of magnetic field.
Nine by two U I by I by A.
9 by 2 mu naught
U R U naught I by pi A.
I by pi
Pi A.
pi A. Okay, Apura, are you getting the same answer?
No, sir, I am getting 3 root 3 u naught by 2 pi a.
3 root 3. Okay, so this total side length is A. So half of this would be A by 2. What I need is this distance. So to calculate this, I would make a triangle. So this angle total is 60, so half angle will be 30. I need this. This is my A or R. So to calculate R, I will write R divided by A by 2, that is tan 30. So R will be A by 2 tan 30. So if I write the magnetic field, that will be mu naught I by 2 pi A by 2 tan 30. Tan 30 is 1 by root 3. So A by 2 root 3. So mu naught I by 4 pi. Mu naught I by 4 pi. और R की जगह A by 2 root 3. And then sine phi 1 plus sine phi 2. So this will be 30 degree, 30 degree. Sine 30 plus sine 30, that will be 1. Half plus half will be 1. And this whole thing multiplied by 3 because all the magnetic field will be added up. So I'll get B is equal to sine 30 half of 1, 3 root 3. 3 root 3 mu naught I by 2 pi. Apurva, is this your answer? Okay, Nupur and Mehul, are you getting this answer?
Yes, sir.
No, sir, I got loose now. I got 3 by 4.
3 by 4. Okay. So I think this method is right. So correct this. So the main task here was finding the distance between O and the wire. So this was the first part, that is the magnetic field. Second, third, and fourth. Nupur, after this, you tell me the value of magnetic dipole moment. Then that is NIA. Then torque, M cross B, and the potential energy. That will minus M dot B. Of course, the direction for this will be out of the plane. Solve this.
How can we write UN cross product?
How can we write what?
U in terms of cross product.
U in terms of cross product. No, we don't write U in terms of cross product. It's a scalar quantity. Nupur, tell me the value of magnetic dipole moment.
Root 3 IA.
Root 3 by 4 A square into I. Root 3 by 4 A square is the area, no?
Yes.
Area of a right angle triangle. And the direction of this magnetic dipole moment. For the direction, you have to curl your fingers along the loop. If you curl your fingers along the loop, your thumb will point, right hand thumb will point in the outward direction. So here it will be out of the loop. Then tell me the value of torque. You already have the magnetic moment. You know the magnetic field is along the x-axis, that is perpendicular to your magnetic moment, which is in the outward direction. So this will be root 3 by 4 I a square into b, and m cross b. M is in outward direction, b is in the x direction. So your torque will be in the upward direction. So direction of torque is upwards. You can also write J cap if you want. Then potential energy will be just 0, because they both are perpendicular to each other. Okay, moving on to next question. So we have an equilateral triangle, and it is kept in a magnetic field, B naught. And current in the wire is I, anticlockwise. So I'll mark this segments as A, B, C, and the side of each side is of length A. So find net force on the triangle. Net force on triangle ABC. Find net force on triangle ABC. Solve this.
Where I am not able to solve.
Okay, first you can calculate the force on, let us say, BC. So force on BC, can you tell me, Apurav? Formula is simple. I straight wire है तो L cross B, that we can use. So L cross B is the angle between L vector and B vector. So what is the angle between length and magnetic field for BC?
They are parallel.
They are parallel. So angle will be 0. Force on BC will be 0. No?
Yes, sir.
So force will be 0. Then we can calculate force on AB, let us say. So length is along this direction, and this is along this direction. So what is angle between L and B?
Sir, 120.
120. And अगर क्रॉस प्रोडक्ट करते हैं लेंथ और बी का, सो डायरेक्शन किधर आएगा? ये लेंथ वेक्टर है, बी वेक्टर है, फिंगर्स कर्ल करना है लेंथ वेक्टर से बी वेक्टर की तरफ.
Sir, outward.
Outwards. Good. So direction is outwards. Then third one is length vector is along this and v vector is along this. सो एंगल कैलकुलेट करते टाइम दोनों के टेल को एक पॉइंट पे रखते हैं, तो दिस विल बी द एंगल बिटवीन AC and the magnetic field. So force on AC, that will be again ILB. It is called, we call this angle as theta dash. ये वाला theta. Tell me the value of theta dash.
Sir, 120.
120. And the direction of force L plus P कितना आएगा? का डायरेक्शन कितना आएगा? किधर आएगा?
Sir, inwards.
Inwards आएगा. Good. So net force देख सकते हैं. Net force is the vector sum of all the forces. That will be F of AB plus F of BC plus F of AC. So F of AB is ILB sine 120. Sine 120 minus half होता है. Then F of BC is already 0 and F of AC is ILB sine 120, but into the plane है. अगर मैंने outwards को positive लिया तो यहाँ पे एक minus sign पहले से ही लगा दूंगा. And sine 120 is minus half. So total will come out to be 0. So net force on this triangle in this magnetic field is 0. Is it clear?
Yes.
Take it. You can note this down and we'll do some more questions. Okay, in the next question, the magnetic field is into the plane. This region, and we have to find force on this shape, magnetic field. The value of magnetic field is V naught, and we have to find force on this equilateral triangle. The side is, and right side as ABC, and the length of side is A. Find the force on this triangle. Magnetic field is uniform everywhere, and the value is B naught. The value of magnetic field is B naught, and the direction is into the plane. Apurav says 3IAB. I think 3IAB might not be correct. Mehul, what's your answer?
Sir, I couldn't figure it out.
Okay. Acha, Mehul, tell me. I first will calculate the force on AB. Let's do it together. So force on AB, that will be I LB sine theta. Tell me the value of sine theta. Tell me the value of theta. Angle between L and B. It's AB, not. Okay, let me give you the current I like this. What's the angle between the current and the magnetic field?
Sir, are they perpendicular?
Yeah, they are perpendicular. So I'll write sine 90 degree. And what's the direction of the force?
Inward?
No. You'll curl your fingers. IL cross P. This vector cross inside vector.
Towards the left?
Towards the, perpendicular to the rod and towards the left. That will be force on AB. This will be force on AB. So I will write the direction like this only, but okay, that's the direction. Similarly, calculate the direction on BC and CA, and then calculate the net force. Mehul, tell me the answer.
Sir, they're all towards the center, and I got 3 IAB not.
There are vector forces, so I'll write the values as IAB naught, sine 90 only, IAB naught sine 90, and 3 vectors which are towards each other. So they will cancel out each other. If 3 vectors are towards each other, they will cancel each other out if they are equal. This is force on BC. I'll just extend them out at the center. This is force on AC, and this is force on AB. All these 3 will cancel each other out, and F vector, that is force on AB plus force on BC plus force on CA, that will be equal to 0. This is cancelling each other out because all the values are equal. You can use vector sum to verify this.
Sir, how are they cancelling?
First, we can do one thing. We can find the resultant of 2 vectors. So these 2 vectors, the angle between them is 120 degrees. Apurva, are you okay with this diagram? 3 vectors, angle between them
Yes,
is
sir.
okay.
Yes.
So I'll find the resultant between these 2. So there is this resultant of AC and AB. Let me call this as F dash. That will be equal to, इसको F naught बोल देते हैं क्योंकि तीनों की वैल्यू F naught है. So F naught square plus F naught square plus 2 F naught square cos 120. Cos 120 होता है minus half. तो ये F dash भी F naught आ जाएगा. तो बेसिकली F naught फोर्स ऊपर लग रहा है और इन दोनों का रिजल्टेंट हो जाएगा F naught नीचे की डायरेक्शन में. And they both will cancel out to result net force as 0.
Yes, sir. Understood.
Let us do one more question. This time the magnetic field is out of the plane. For out of the plane, I will try it like this dot. And you have to find the value of net force on a rectangular loop. This side is call it A, and this side has length B. And the current is anticlockwise. The value of current is I naught. Find force on individual wires, then find the net force. In the magnetic field is uniform out of the plane, the value is B naught. Find net force. And second is you have to find magnetic moment. Third, you have to find the torque. Then you have to find the potential energy. Try this.
Sir, in this case also net force is 0.
Yes, that is right. Net force is 0. So I'll calculate this quickly. Force on this part on AB, it will be towards this side. I'll call it F. The value of F is I naught A B naught. Let me call this as F. And if we calculate force on CD, this will also come as F. So these two forces will cancel each other out. So maybe you can write it like this: force on AB, that is equal to I naught A B naught minus I cap, and force on CD, that will be I naught A B naught plus I cap. Then if we calculate force on DA, that will be again outside. Let me call this as F dash, where the value of F dash will be I naught B B naught, and force on BC will be downwards. This is also F dash. So we can write force on BC, that will be I naught B B naught, and the value will be, the direction will be minus J cap, and the opposite for force on DA, I naught B B naught into J cap. So net force will be sum of all the forces. Force on net force F net, that is force on AB plus BC plus CD plus DA. Or sum of all these four will result in 0. Okay, next question.
Sir, energy is also zero.
Let also find the magnetic moment. That will be IAB. Torque will be 0 because the direction of magnetic moment, it will be out of the plane, and torque is M cross P. So they will be parallel. M cross P, both of them will become parallel. So this will become 0. And U, that is M dot B minus M dot B. So minus MB sine 0 degree cos 0 degree. Magnetic moment is out of the plane. Magnetic field is out of the plane. So this will be I A small b capital B naught cos 0 is 1. So potential energy is minimum. That means this is a case of stable equilibrium. Net force is 0, net torque is 0, and potential energy is minimum. So we can safely write this is stable equilibrium. Stable equilibrium. Moving on to next question. Suppose we have a semicircle like this, starting from A, ending at B. Then value of current, let us say, is 2 pi ampere, or 2 pi ampere, and this radius is given as 1 millimeter. Find magnetic field at O. Find magnetic field at O.
Sir, it will be U naught I by 4R.
Calculate its value. Mu naught I by 2r और theta pi है. So pi by 2 pi. So mu naught I by 4r. Put the values of everything and tell me the value of magnetic. Mu naught is 4 pi into 10 raised to minus 7. I should have the okay. Let's take the current as 10 ampere. So this will become 4 pi into pi millitesla or pi milliweber per meter square. That will be the value of magnetic field at point A. Next question, let us say it is like this. These two are semicircles and current here is 10 ampere. This smaller radius is, call it 1 millimeter, and this bigger is 2 millimeter. This O is the center of both the circles. So current goes like this, here, 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 like this. Find magnetic field at O. So direction here, it will be out of the plane. So here direction will be out of the plane.
रेमोन बंद करने में 2 सेकंड नहीं लगा इसलिए जो
Pura, what are you saying?
सर
मैग्नेटिक फील्ड दोनों की वजह से निकालना है एंड अगर सेम डायरेक्शन में देन यू हैव टू ऐड इट.
it will be 15 pi into 10 raised to minus 7.
And the direction will be
Outward.
so mu naught I by 4 R1 plus mu naught I by 4 R2. I can take mu naught I by 4 common. That will give me 1 by R1 plus 1 by R2. Three by 2, 1.5, 15 pi into 10 raised to minus 4. So 1.5 pi millitesla. Verify if this is correct and you're getting the same answer. If not, then correct your calculation and see if this answer is coming. Okay, moving on to next question. So suppose we have an arrangement like this. We have two straight wires. And then two semicircles. Or let me say they are infinite wires. Semi-infinite wires. We have to find magnetic field at this point, P. And let us say this distance is given as A. That's the radius of the semicircle. And current is coming like this. Value is I naught. Then going through the semicircle. And then going back to the semi-infinite wire. Semi-infinite means this part is an infinity. Find magnetic field at point P at the center. See, for this semi-infinite wire, I'll calculate the magnetic field by this formula. Let me call this as P1. So it will be mu naught I by 4 pi A and cos sine 90 plus sine 0. So that will be just this much. Sine 90 plus sine 0, that will be 1. And if you calculate the magnetic field, it will come up out of the plane. That is due to this wire, I'll call it P1. Due to this wire, I'll call it B2. So B2 will be mu naught I by 4 pi A. And here also it will be sine 0 plus sine 90. And this one will go again out of the plane. So mu naught I by 4 pi A, mu naught I by 4 pi A for both of them. And then magnetic field due to the circular wire, that is half mu naught I by 4A. And this will also be out of the plane. So all the magnetic field are out of the plane. So they will get added up. So net magnetic field, that will be mu naught I by 4 pi A, 1 plus 1, that will be 2. And here to take pi common, I'll multiply by pi. So this will be pi plus 2 mu naught I into 4 pi. And the direction is out of the plane. Is this clear? See, calculation is very easy because you already remember the formulas. Of course, you have to memorize the formulas. The direction can be a challenge. So that for that, you can either take a very small element or you can use your right hand thumb rule and easily figure it out.